today I'm going to talk to you about the RICHBOROUGH Connection project, which is a really exciting project that we've been undertaking for the last 7 years at Archaeology South-East. And the results describe 13,000 years of natural and human-induced landscape change in the Wantsum Valley in Kent. We've got a huge team of specialists working on this project, some from Archaeology South-East and some externally. So it's really been a team effort to bring it to this point in time. We're partway through writing the monograph and publication, so we're midway through the process of understanding the results. So these are kind of preliminary discussions on the results that we found. So the outline of this talk, I'm going to describe the study area to begin with, and then go through what we knew about the Wantsum Valley and the environs before we started this project. I'm then going to discuss the aims of the project and the methodologies employed to address the aims, and then dip into a selection of the results that we've found so far. So partially focusing on the Lake Glacial landscape of northeast Kent, moving on to Holocene sea level rise, and then discussing a few anthropogenic signals in the boreholes that we've undertaken, and then present the conclusions and future potential for the Wantsum Channel. This is primarily a geoarchaeological and palaeoenvironmental project, and it's based on a large borehole transect that we undertook through the Wantsum Valley. The Wantsum Channel itself used to divide the Isle of Thanet from mainland Kent. It's 20 kilometres in length and roughly 5 kilometres in width at 0 metres OD. And in the past, it would have been a colossal landscape feature, highly significant. Whereas today, if you were to walk this landscape, you wouldn't be able to see it at all. It's almost totally filled in. So over millennia, through both natural and anthropogenic processes, the channel has filled with sediment. The transect that we've undertaken is one of the largest geoarchaeological transects undertaken in the UK. And it was undertaken in response to the installation of an overhead line by the National Grid, who have funded this project. The Thames estuary is to the northwest of the site, and the North Sea is to the east. So if you imagine where the yellow is in the centre of this picture, this is where the alluvial floodplain sediments have accumulated, and water used to flow throughout this central location. So regarding previous studies undertaken in the Wantsum Channel, they're relatively few and far between, and they've tended to focus around Sandwich due to people undertaking boreholes in response to development of the town. And so we've got a really biased view of the history and evolution of the Wantsum Channel. This long borehole transect is our own, and then there's sporadic palaeoenvironmental sequences that have been studied in this landscape, but a lot of the sequences don't have any dating associated with them. And so we're really starting from a place of not very much knowledge regarding the evolution of this channel. So I'm going to start by summarising what we knew before we started the project, starting in the Lake Glacial Interstadial, because, spoiler alert, we found Lake Glacial Interstadial sediments at the base of the channel. These are really rare to find. You don't find them in many locations. So this was very exciting and slightly unexpected. So the Lake Glacial Interstadial is a period of warming towards the end of the last glacial period, spanning from 14.7 to 12.9 thousand years ago, where temperatures rose to similar levels to today. The most interesting thing about this period, from what I've found, is that sea levels are relatively unknown during this period. They're estimated to be at minus 40 to 50 meters OD, but this is based on computer modelling, and we don't actually know where sea levels were at this time. There are very few studies. So moving forwards in time to the early Holocene, the base of the Wantsum Channel was likely comprised of freshwater braided channels, and the land bridge was still intact between mainland Europe and Britain. And sea levels started to increase quite rapidly, and as the climate ameliorated. So over time, the sea encroached on the eastern coastline of Kent, and we have some dates from Sandfield Farm that suggest the inundation of the northeastern tip of Kent occurred in around 5.2 to 4.7 thousand Gal BC. When we know that, well, studies have suggest that the inundation event of Doggerland occurred in around 6,200 BC. So during the late Mesolithic, the sea is encroaching on northeastern Kent, but it's not yet started to fill the channel. Moving forwards in time, so as time moves on, the channel begins to fill. A few islands appear in the base of the channel that are rather attractive to past people who occupied this landscape. Shingle spit started to move onto the eastern coast of Kent, and somewhere between the Neolithic and Early Bronze Age, the Wantsum Channel became a tidal channel linking the North Sea to the Thames estuary. So it provided a through route, sort of cutting off the top of Kent. And studies suggest that from around the Iron Age to Roman period, the channel was at its highest tidal limits and was a navigable body of water. So this was a really attractive location for past people occupying the northeastern tip of Kent. They were attracted to this, the estuarine resources in the base of the valley, wetland formation, fishing, trade, and especially routeways to Canterbury and through to London. And people also were attracted to grazing and agriculture on the valley slopes. So this is a distribution of finds from the HER data. They are inherently biased because of collection bias, but they kind of highlight where people were occupying the valley slopes around the edges of this large valley. I should say this is from the Neolithic to Roman period. So most dramatically, RICHBOROUGH Island, which is this green blob here, became the gateway to Roman Britain. So this is where the Roman invasion occurred. It's the site of the Claudian invasion, where it said that 40,000 troops landed in Britain. And they built a fort, the Romans built a fort at Richborough and at Reculver in the northern end of this channel, thereby controlling the passage through this channel. The settlement at Richborough extended over 21 hectares and includes temples and an amphitheatre, so they really landed hard in Richborough. Moving slightly forward in time to the later Holocene, the focus shifts away from Richborough Island and slightly further towards the eastern mouth, towards Sandwich. And we think that this shift occurred because of these shingle spits that are growing along the eastern mouth, kind of are constricting this channel. So Sandwich is here, and it's occupying another one of these island, or what we're calling island locations in the base of the valley. Over time, the channel has started to silt. So from the Neolithic periods onwards, as people are occupying the valley slopes, destabilizing soils, practicing agriculture, this is causing runoff into the base of the valley, and it has begun to silt. And this is exacerbated by these shingle spits that are forming across the eastern mouth of the channel through longshore drift. People were also keen to reclaim the marshlands that were forming due to their high fertility. And Sandwich grew in importance because of this naturally occurring haven in the eastern mouth of the channel. So Sandwich was a highly significant town. Most interestingly, in 1287, there's a known storm that really impacted the whole of the southeastern coast of Britain, and it really choked up most of the major harbours that were around the coastline, like Winchelsea, Rye and New Romney. And it certainly took a real hit on this coastline, where this deal spit significantly grew during this 1287 storm. So, as I said, Sandwich is extremely historically important. It was ranked in the 20 largest towns of England. So very Canterbury, with large amounts of herring, popular anchorage for the English fleet of Edward the Confessor. And it, similarly to the Romans, they understood this strategic location in order to control trade routes through this channel towards Canterbury and the Thames estuary. And finally, the closing of the Wantsum Channel, it completely silted up, apart from this very small river that remains, the River Stour. By the 16th century, Sandwich had really declined as a functioning port, and it now lies a couple of miles inland. You wouldn't understand why it was a fully flourishing port in the past. And from reading some historical sources, this was deeply distressing to the local inhabitants. They could see changes within a lifetime. So this is what the Wantsum Channel looks like today. This is a picture of from Google Earth. It's just a very flat landscape. You just would not believe that a giant channel lies beneath your feet if you were to visit it today. This is the Stour River heading eastwards. The aims of the RICHBOROUGH Connection project were to provide a palaeoenvironmental context for the extensive record of prehistoric, Romano-British and later settlement that occupied the downland ridges, as well as those in the island locations within the valley base. The second aim was to investigate the onset, degree and extent of marine influence on the topographic development. And thirdly, to pursue an extended understanding and assimilation of known heritage assets and previous archaeological and geoarchaeological work in order to contribute to a synthetic history of the wider Wantsum Channel. So we started off with this 12-kilometre transect across the valley. And 7 years ago, we cut open 200 metres of coring. It took us 2 weeks with 6 people. We had to wear full body suits when we cut open the cores because it was just plastic dust everywhere. And we took photos, we subsampled for pollen, diatoms, foraminifera, ostracods, insects, plant macrofossils, mollusks, as well as other proxies. And this began an iterative process of us trying to decide which of these boreholes were the most exciting, which ones had the most high resolution preservation potential. So we took 2 main stages of assessment, but it actually was probably more like 5 or 6 micro stages of assessment, just trying to narrow this 39 boreholes into something manageable. So we chose 4 to take to full analysis, although we have a huge amount of data from the other boreholes in this scheme. And the 4 that we've chosen are 26, 37, 47 and 60, so evenly spread throughout this landscape. We also undertook an extensive program of dating. Before the project started, I think there were only about 10 dates available, and they were all from the eastern mouth, and they were all Mesolithic, which is very helpful. Now we have an extra 66 dates to add to our body of knowledge, and so we significantly enhanced our understanding of the chronology of the development of the Wantsum. Tom Hill undertook pollen and diatoms analysis, a huge amount of samples, and this provides the main bulk of our understanding of the evolution of the channel. John Whitaker undertook the ostracod and foraminifera analyses, and I actually took these scanning electron microscope images in the basement last year with some of you here. So they look really nice. This is a preliminary deposit model that we need to update following the assessment, but it gives you an idea of the range of deposits encountered in the range of depths. So this model is slightly confusing because it's not a cross section, it goes down the length of the borehole transect. So this is a cross section across the channel, but this goes down the channel towards the east. So the most exciting thing is this huge anomaly in depth at borehole 37, which reaches -25 meters OD. This is huge, and just to illustrate it, this is the Institute of Archaeology building, and it definitely fits within this gap in the channel. So it's probably the equivalent of a 9-story building that you can fit in this borehole. So this is really intriguing. It's much deeper than any borehole somebody had found before in this channel. We don't know exactly what formed it. So this is one of the most interesting parts of this project. I'm going to start to summarize the results now in chronological order. So the base of borehole 37, this grey, this is the late glacial interstadial context. So we're back in this warm period towards the end of the late glacial, and there are very few records from this period, particularly from Kent, although we have a really nice record from Holywell Combe. But any extra information on the environment of this time is really contributes to our understanding of this period. The pollen and diatoms describe a shallow freshwater setting. So these are the types of flora that you might have seen at the time: water milfoil, cattails, mugwort, meadow rue, and buttercup. So it's grass sedge tundra with some birch and pine and hazel. And when you compare this with Northwest Europe, pine and hazel were not universally observed in Northwest Europe. So there's a growing body of data to suggest that there are pine and hazel in small amounts during the late glacial interstadial. These are relatively preliminary results, but at Holywell Combe, they undertook a temperature reconstructions using beetles, and it suggested that the July maximum was 70 to 18 degrees and January minimum -2 to -7. And I have then gone back to their data and reconstructed the temperatures using ostracods from that same site and using Dave Horn's motor method. And the results suggest that temperatures were 20 to 23 degrees in July, the maximum in July, and -3 in January, and then done the same for the Wantsum Channel. And we've got similar results, although it looks like it could have gone to -8 degrees in the Wantsum Channel. This is interesting because the July temperatures are similar to today, but the winter temperatures are a little bit colder. So there's sort of a growing body of data to sort of reconstruct these temperatures from the late glacial interstadial, but the data so far suggests that although it was cold in the winter, in the summer, it could have been an attractive place for people to travel to. Regarding sea level rise, so this is the period where we don't really know where sea level was at the time, and a lot of models suggest that it's right the way down here in the minus sort of 40 and 50 meters OD range. In the base of borehole 37, the Institute borehole, the freshwater environment is situated at minus 20 to 25 meters OD, but there is repeated appearance of marine diatoms, ostracods and foraminifera throughout the sequence. This points to a possibility of marine encroachment during this period, which is rather interesting and possibly anomalous. You could argue it could be reworking or contamination through the drilling process. However, we've recently undertaken a borehole in Newhaven in East Sussex on the south coast and found something very similar, 24.9 meters OD, same height, salt marsh present, same date, late glacial interstadial. And speaking to my colleagues in the southeast of England, there are rumblings that people are getting similar dates from their sequences. So I kind of am expecting maybe in the next few years to try to understand this period a bit better, maybe get some more evidence to suggest that sea level rise was not a linear process during the late glacial, and perhaps these very warm temperatures that we were experiencing contributed to rapid sea level rise. Moving forwards in time, we've so after the early Holocene period, we've got rapid sea level rise and increase in temperatures, and the Wantsum Channel starts to fill with marine water. And the timing of this is rather interesting. A lot of our results corroborate the sand-filled farm dating that the inundation, there was an initial inundation at 5.2 to 5.4 sort of Cal BC at around -6 meters OD. Sometimes there's differing levels of compaction, so I'm not sure about the discrepancy in meters OD, but there's certainly an earlier inundation event, then there's a pause, and then there's a later inundation event. And our borehole 60, which is closest to the mouth, corroborates the sand-filled farm date that it happened around 4.6 to 3.7 thousand Cal BC at -5, roughly -5 meters OD, which is fits in exactly with predicted sea level curves for this time. However, borehole 37 records a marine inundation at -18 meters OD and dates it to just after this inundation at the coast. So you would expect there to be a lag in time as sea levels rise. It's going to hit this area later on, but -18 is pretty extreme. That's a 13-meter difference in height. So essentially, this is the eastern end. Water is coming in at -5, the sea level, and coming across and reaching this anomaly, perhaps. And the sea level inundation is recorded here. So this is a major question for us to consider during the publication of this data. We're not entirely sure how this has happened, but perhaps this was an isolated, deep anomaly in the landscape, and it just simply filled in quite rapidly as sea level finally encroached on this area. We just don't know. We need to, more research needs to be done into this, really. So moving on, we're moving forwards in time to the late Neolithic. So the Wantsum Channel is filling with marine water. And meanwhile, in borehole 26, this is our most inland borehole. This is totally different from all of our other boreholes. This is a totally continuous freshwater peat sequence. There's no inundation events, there's no hiatuses, there's no truncation or erosion. We've simply got at least 1,500 years worth of peat accumulation without any pause. The dating suggests that it was accumulating pretty regularly, and so this is important for the pollen record because it means that any pollen that's taken from the sequence is going to be really reliable and for interpreting the trends in the evidence. So our pollen specialist Tom has found a lime decline in the late Neolithic that fits well with overall trends of lime decline in the UK. So there's no marine inundation, no hiatuses. So this points to anthropogenic woodland clearance in the local area. We can't see any other plausible explanation for this, and the appearance of cereal pollen and the appearance of many Neolithic monuments in the area suggest that people were clearing woodland. And it's widely understood that human agency was the main driver for reductions in woodland cover during the mid to late Holocene. This is the lime decline in the sequence, and we present this as convincing evidence for artificial landscape modification and strengthens the case for our regional understanding of the lime decline. So people are actively modifying their landscape and the slopes, contributing to the destabilization of soils and hill wash into the valley slopes. For the Bronze Age, the channel's still filling with water. We've got beach appearing, which is a biostratigraphic marker because it migrated to Europe in response to climatic amelioration. And beach is also good at colonizing formerly deforested areas. So this could be another point of interest, potentially pointing to anthropogenic woodland clearance. And some dung beetles also attest to herbivore grazing. So the woodlands of England or southeast England were becoming increasingly more open, and this fits with regional models. The Iron Age and Roman period is interesting because of the complete lack of data from these periods. Out of 66 dates, only 2 Iron Age and Roman dates were returned. And they both came from high energy beach sands and gravels, which really supports this idea that it was a highly dynamic environment of this time. Water was flowing pretty rapidly through the channel. It was at its reach of its tidal limits, and it's probably scoured away much of the softer sediments, and we just don't have any preservation of Iron Age or Roman fine-grained deposits at all. This also coincides with a climatic shift to stormier conditions during this time. Closing the results section of this presentation, we've got a really nice medieval sequence preserved in borehole 60, which is in the eastern mouth of the channel. And at minus 3.55 meters OD, there is an unconformity and a jump from the Bronze Age to the High Medieval period, missing, shockingly, Iron Age and Roman periods. So again, this attests to this really dynamic environment that's eroding sediments away during this period. And sediment accumulation recommences in the High Medieval period. Interestingly, we can't really get very precise dating on this sequence because we're using OSL, which is in itself not an extremely reliable, it's not a precise dating method. There's not enough organics to do radiocarbon dating, so we're kind of we can't narrow it down much further than this, but the 1287 storm occurred and really it closed off the mouth of the eastern mouth of the channel quite rapidly. And this is possibly signifying when sediment accumulation started again, this really fine-grained silts and clays that normally form behind coastal barriers. So it could point to the 1287 storm or just continued growth of these shingle barriers across the eastern mouth. We also have peaks in bracken and fern, often associated with deforestation and or burning, and continued silting of the channel through destabilization of the valley slopes. This sequence in particular, during the High Medieval period, we had the largest or the greatest abundance of dinoflagellate cysts, which I didn't know what they were before this project, but they're these. And apparently the London clay has a huge amount of dinoflagellate cysts that look like this. So this is the London clay bedrock. So we're thinking that this indicates substantial erosion of the London clay nearby, even more so than any other period before this, or a newly exposed section of the London clay. So we're positing that this reflects the use of the valley slopes for agriculture and deforestation. And finally, there's the presence of cereal grains to support our to support the fact that there was agriculture being undertaken. So to conclude this presentation, we had three clear aims at the beginning of this project: to provide a palaeoenvironmental context for the extensive record of prehistoric Romano-British and later settlement that occupied the downland ridges and the island locations. And we found that the Wantsum Valley preserves a unique, valuable and detailed record of landscape evolution spanning 13,000 years, and that the changes to the Wantsum Channel landscape have both influenced and been influenced by the human communities that occupied and utilised the surrounding valley slopes. And significantly, artificial modification of the landscape led to increased surface erosion and contributed to the silting of the valley. This, coupled with natural processes such as longshore drift and the storms, closed the once active and vital historic maritime trading route. And the second aim was to investigate the onset, degree and extent of marine influences on the topographic development of the Wantsum Valley. And we've used micropaleontological analyses to reveal the impact of changes in the climate and corresponding sea level in the development of the region from the late glacial through the Holocene. And finally, we want to pursue an extended understanding and assimilation of known heritage assets and previous archaeological and geoarchaeological work to contribute to a synthetic history of the Wantsum Channel. And this part is ongoing. We're midway through sort of assimilating all of the known heritage assets, previous palaeoenvironmental reports. So we're in the process of drawing all of this information together, only part way through. So I'm sure there's going to be a few more results that will come out of this project in the next few months. Future work, this is a huge landscape feature. It's really complex, and we've certainly not answered all of the questions that there are to ask of this valley. So the first question is, does the late glacial interstadial marine signal in fact represent the encroaching sea? And where were sea levels during the late glacial interstadial? This requires a lot more work. Was there indeed, I mean, I'm calling this waterfall, but having spoken with Matt, we're rewording, but this colossal infilling of this deep anomaly, was there in fact this anomaly during this time, or has some process created a solution hollow later on? Has there been reworking? This is all relatively unclear and remains an open question. We're also lacking high resolution paleoenvironmental information from the Iron Age and Roman periods. And I understand that work is being undertaken at RICHBOROUGH Amphitheatre by Historic England right now. And they are really interested in trying to find some really high resolution sediments to study in order to reconstruct the paleoenvironment of the Roman period, to try and put the Roman invasion into its environmental context. There's perhaps some areas of backwater that were not affected by erosionary processes that we could explore. And finally, we need to do more work on the northern end of the Wantsum Valley. We're lacking data from that end, and this could help to understand things like this really deep anomalous feature. So thank you very much for listening. Thank you to everyone who worked on the project. Yeah, thank you to the Simon Mason, county archaeologist, and Jane Corcoran from Historic England for their advice and guidance throughout this project, RSK for commissioning the work, nationalgrid, and Lauren and Fiona for producing the wonderful figures. Many of the figures are actually going to be published in our sandwich monograph, so I've pilfered them for this presentation. They're going to be in our sandwich monograph. So thank you very much for listening.